This is CBSE NCERT Solutions, chapter number 4, Quadratic Equations, exercise 4.4, problem number 2. The problem is find the value of k for each of the following quadratic equations so that they have two equal roots. Okay. The very first equation is 2x squared plus kx plus 3 equal to 0. We want to find this value of k, and it is given to us that this equation has equal roots. We know that we have three different cases. The equation, if the value of discriminant of any given quadratic equation is greater than 0, then we have distinct and real roots. And if value of d is equal to 0, then we have real and equal roots. And if value of d is less than 0, we have no real roots. But it's given to us now that the equation has equal roots. So we are under this category now. So if roots are equal, it means that the value of discriminant for this quadratic equation must be equal to 0. So let's find the value of the discriminant. We have discriminant equal to b squared minus 4ac. This is the discriminant. This is the formula for discriminant. And in order to find the values of a, b and c, we compare this quadratic equation with the general quadratic equation, which is ax squared plus bx plus c equal to 0. Comparing both of these equations, we get a equal to 2, b equal to k, and c equal to 3, because it's a here, 2 here, k here, b here, so b is equal to k, and c is here, 3 is here, so c is equal to 3. So value of d is equal to b square is k square minus 4 times a is 2 times c is 3, because it's given that this equation has equal roots, so we have this thing equal to 0. So I can write d is equal to k square minus 4 times 2 is 8 and 8 times 3 is 24 equal to 0. So I get here k square equal to 24. So k is equal to plus minus square root of 24, and square root of 24 is, I can factorize 24 into 2 times 2 times 2 times 3, and it's equal to plus minus 2 square root of 6. So I have k equal to 2 under root of 6 and minus 2 square root of 6. So these are the values of k, and this is the solution for this quadratic equations. 2x squared plus kx plus 3 equal to 0, and we needed to find the value of k, and here's the value of k. We get two values of k. And the second problem is we have kx times x minus 2 plus 6 equal to 0. It's also given to us that this equation has equal roots, so the value of discriminant for this quadratic equation must be equal to 0 according to these categories, and we fall under this category. So let's find the value of the discriminant, and in order to find the value of discriminant, we compare the above equation with general quadratic equation, but we need to modify this equation first. We can also write this equation like that: kx squared, because I'm multiplying this kx with x, I get kx squared, and minus 2 times kx, I get minus 2 kx plus 6 equal to 0. Now comparing this equation with this equation, I get a equal to k, b equal to minus 2k, and c equal to 6. So value of discriminant d is equal to b squared minus 4ac, and it's equal to b squared, it's minus 2k square minus 4 times a is k, times c is 6, and it's equal to 0 because it's given that roots are equal. I repeat it again. So I get minus 2k square, it's 4k square, and minus 4k times 6 is minus 24k equal to 0. Now I can take 4k common from these two terms, and I get k minus 6 in the brackets, and it's equal to 0. So from here I get k equals 0 and 6. because either k can be equal to 0 or k can be equal to 6 in order to make both of these sides equal to 0. So I get two values of k here, but the interesting thing here is, let's go through the basic definition of a quadratic equation. Any equation which is in the form of ax square plus bx plus c equal to 0 is a quadratic equation such that a not equal to 0. Here we have this thing, and here k cannot be equal to 0, because if it becomes equal to 0 it won't be a quadratic equation anymore, so it will become a linear equation. So k cannot be equal to 0 actually, so that's why we discard this value. So here we can only consider k is equal to 6, which is the solution for second part. I will repeat this thing again. Any equation which is in this form, ax square plus bx plus c equal to 0, where a not equal to 0, or we can also write any equation which is of the form kx square plus, you can consider any number here, tx plus b equal to 0, where k not equal to 0 is a quadratic equation. You can also say that. So k cannot be equal to 0 here. So if I get k equal to 0 here, I will have to write 0 here. And if this whole thing becomes 0, this won't be a quadratic equation anymore. That's why k cannot be equal to 0. So I only need to consider k equal to 6, which is the solution of the second part. And in the next video I'll be covering chapter number 4, quadratic equations, exercise 4.4, problem number 3. See you guys.